Chapter 7, Miscellaneous Exercise. Question number 31. Question says, integration 0 to pi by 2 sine 2x tan inverse sine x dx. We can write it 0 to pi by 2 sine x cos x times tan inverse sine 2x dx. Sorry, sine x dx. Let sine x equal to t, cos x dx equal to dt. So let's change the limits. When x equal to 0, then t equal to 0. When x equal to pi by 2, t will be equal to 1. So our question will change to 0 to 1 to t tan inverse t dt. Now here we can use integration by part. We can take this first function and this is second function, and then we can apply the rule integration first into integration of second minus df and dx of first into integration of second whole times dx. So this can be easily solved. Now let's go to question number 32. Question 32 says 0 to pi x tan x divided by sec x plus tan x dx. 0 to a fx dx equal to 0 to a minus x dx. This property we can apply here. Suppose this is I. So I equal to 0 to pi minus x tan pi minus x dx divided by sec pi minus x plus tan pi minus x. Tan pi minus x is minus tan x. Sec pi minus x is also minus sec x. So it will become 0 to pi, from here minus sign common, pi minus x tan x divided by minus common sec x plus tan dx. Suppose this is equation number 1, this is equation number 2. Adding 1 and 2. 2i equals 0 to pi. From here, x will cancel out and we will get pi tan x dx divided by sec x plus tan x. Now we convert tan x to sin x upon cos x and sec to 1 upon cos x. So 2i equals 0 to pi times sin x upon cos x dx divided by 1 upon cos x plus sin x upon cos x. So cos x will be common and that will get cancelled. So 2i equals 0 to pi times sin x divided by 1 plus sin x dx. Now we multiply and divide by 1 minus sin x. It will become 2i equals 0 to pi times sin x times 1 minus sin x. And when 1 minus sin x is multiplied to 1 plus sin x, it becomes 1 minus sin square x. So let's write it as cos square x dx. Now we divide each term by cos square x. So 0 to pi, we can keep pi outside. Then sin x divided by cos square x will give tan x times sec x minus sin square x divided by cos square x will give tan square x dx, which can be further written. So it will become pi times 0 to pi tan x sec x minus, this can be written as sec square x minus 1 dx. So we can split the integration keeping pi outside. So pi, then integration 0 to pi tan x sec x dx minus integration 0 to pi sec square x dx plus integration dx 0 to pi. Now integration of tan x sec x is sec x, integration of sec square x is tan x, integration dx is x, and then we can put the limits to get this. So it is simple. Now let's go to question number 33. Question number 33, 1 to 4 modulus x minus 1 plus modulus x minus 2 plus modulus x minus 3 whole dx. Here there are two methods of solving the same question, but I am going to adopt the simpler one. So I will split each term and then I will apply the rule of the modulus and then integrate. So 1 to 4 modulus x minus 1 dx plus 1 to 4 x minus 2 dx plus 1 to 4 x minus 3 modulus dx. This function will be negative. Here if we put value x equal to x minus 1 equal to 0, so we will get x equal to 1. Means below 1, this function will be negative. So since lower limit is 1, so this function will never be negative. So if we write it like 1 upon 4 x minus dx, and then we integrate, we will get the value of this. Now we can consider separately our terms. Here, if we write x minus 2 equal to 0, we will get x equal to 2. So below 2, this function will be negative. So we can split the limit like 1 to 2, then we write minus of x minus 2 dx, and then from 2 to 4 it will be positive. So 2 to 4, then x minus 2 dx, and then we can easily integrate. Consider this. If we put x minus 3 equal to 0, we will get x equal to 3. It means from 1 to 3, this function will be negative. So we can write 1 to 3 minus of x minus 3 dx plus from 3 to 4 it will be positive. So 3 to 4 x minus 3 dx. And now it can be easily integrated. Let's go to next question. Question number 34. Integration 1 to 3 dx upon x square x plus 1. It is simple question. It can be solved by using partial fraction, that is 1 upon x square times x plus 1 can be written as a upon x plus b upon x square plus c upon x plus 1. Then we can get the values of ABC. Then we can easily integrate by putting value. So this will become a upon x a will have certain value. The integration of this will be log x times a. Similarly, this will become x power minus 2 plus 1 divided by minus 2 plus 1, and this will be log. So this can be done. Let's go to question number 35. Question number 35 says 0 to 1 x e power x dx. So here we can apply Eilert rule, in which this will be taken as first, this will be taken as second, then we can put the values and we will get answer as well. Let's go to question number 36. Integration minus 1 to 1 x power 17 cos power 4 x dx. We know that minus a to a fx dx becomes 0 if fx is an odd function. Here cos power 4x is even, but x power 17 is odd. So total function will be odd, hence its value will be 0. Question number 37. 0 to pi by 2 sine cube x dx. This can be written as 0 to pi by 2 sine x into sine square x will become 1 minus cos square x dx, and then let cos x equal to t, then minus sine x dx equal to dt, and we can change the limits. When x equal to 0, then t will be 1. When x equal to pi by 2, t will be 0. So our question will become 1 to 0, 1 minus t square, and sin x dx will be minus dt, so minus sign we can keep outside it. Then we can easily integrate. Now let's see question number 38. Integration 0 to pi by 4 2 tan cube x dx equal to 1 minus log 2. This is the answer. So let's simplify it. So 0 to pi by 4, we can keep 2 outside, tan square x times tan x dx. Then y of 0 to pi by 4, tan square x can be written as sec square x minus 1 times tan x dx. This can be further written as twice of integration 0 to pi by 4 sec square x times tan x dx minus 0 to pi by 4 tan x dx. Here, if we put tan x equal to t, then sec square x dx will be dt, and it can be easily solved. Here, integration of tan x is equal to log sec x. So after putting these values, one can solve it. It is simple. Now let's go to question number 39. Integration 0 to 1 sine inverse x dx equals pi by 2 minus 1. So here we can take 1 as another function. So here first we write sine inverse x, then 1 dx, 0 to 1. We apply integration by part. So sine inverse x in integration dx minus d upon dx of sine inverse x. So that is 1 upon root of 1 minus x squared times integration dx, limits 0 to 1. So we should not put limit here. We will put limit after work is done. So it will become sine inverse x times x minus. Now here we can put limits 0 to 1 minus integration. Dx will give x. So x upon root of 1 minus x squared dx 0 to 1. It is very simple. Here let 1 minus x squared equal to t, then minus 2x dx equal to dt, and then x dx will be minus half dt. And we can change the limits also. When x equal to 0, t will be 1, and when x equal to 1, t will be 0. And then after putting the limits, we can get to the value. Thank you for watching.